Okay, good morning students. Today I am going to explain you the process state diagram. Now what actually the process state diagram is. Now basically there are different states through which process goes during its life cycle. Now these states are like new state, ready state, running state, terminated state, waiting state and so on. Now we'll see in detail one by one how the process goes through these different states during its life cycle. Now when new process is created, so basically initially that process it is present on the secondary memory, and that state of the process is called as the new state. So here the process we can say that it is in static mode, or no other resources are assigned to that process. Okay. Now further the process is admitted in the next state, that is the ready state. Okay. Now admission of the process from new state to ready state, okay, it is handled by one of the scheduler. That scheduler is called as the long-term scheduler. Okay. So long-term scheduler is responsible for admission of the process from the new state to ready state. Now the ready state, it is also called as the ready queue. So it is present in the primary memory, okay, or that is RAM. Okay. Now when process enters in the ready queue, so it has to wait there for the execution. Okay. So it is waiting for the processor for further execution. Now uh, next to that, when the turn of the process arrives in the ready queue for the execution, so it is dispatched to the processor, or processor is assigned to that process. When processor is assigned to that the process, then that process lies in the running state. Now here process is under execution. Okay. Now the selecting the process from ready state and assigning the processor to that process, so it is done by the next scheduler, that is the short-term scheduler. Okay. So short-term scheduler is responsible for selecting the process from ready state and then assigning the processor to that process. Okay. Now when process is under execution, and if it has finished completely, or it is executed completely, then further it terminates. Okay. Terminates means it deallocates all its resources like the memory, and it releases the processor. Okay. As these resources are limited, so they need to be utilized properly. Okay. So it releases the memory, and also it releases the processor cycle. Also it releases the any other IO devices that it is utilizing. Okay. So there are basically two types here of this scheduling when process is in the running state. So that two types are called as non-preemptive and preemptive. So non-preemptive stands for the when process is under execution, it completes its execution, okay, and then it terminates. Now next possibility is preemptive scheduling. So preemptive stands for, okay, preemptive stands for the process executes partially and then it is interrupted, okay, and it goes back to ready state. So it happens in multitasking environment, okay, when multiple processes want to execute. So at that time what happens, the process execute for particular time slot, okay. Once the time slot is finished, then process is interrupted and it again goes back to ready state. Okay. It has to wait in ready state for further execution. Okay. Now, so this type of scheduling is called as the preemptive scheduling. Okay. Okay. Now next possibility is that okay, and when process is under running state, the running process may need some IO. Okay, it is requiring some it requires some input from the user, or it want to read some data from the file which is stored on the secondary storage, or it want to generate some output. So when process is requesting for these IOs, it has to go in wait or block state, because IO is time consuming. Okay. So processor can't wait for completion of the IO. So process need to go in the waiting state and for the completion of its IO. Once the IO is finished, once the IO task is finished, then process again enters in ready state, okay, for its next execution. Now when process goes in IO state, the next ready process from the ready state is scheduled for the execution. Okay, so processor need to be always busy. Okay, it is never idle. To increase the throughput of the system, the processor should always be busy. Okay, so once the process is terminated, or it is interrupted, or the process goes in wait state, at that time next process from the ready state is scheduled for execution. Now next possibility or next case is that okay, when process it is in the wait state. Okay, so wait state, so it is again waiting queue, we can say that. So new process when arrives in this wait state, so it is assigned at the tail of the queue. Now at certain moment it may happen this waiting queue is full, as it is present in the RAM, so it may be the case that there is no further space for the new process which want to reside in this queue. So at that time, that process need to be suspended. The suspended process goes in the secondary storage, or that suspend, we can say that it is the swapping out. Suspend means swap out the process to the secondary storage, or we can say that suspended wait state. Suspended wait state is present on the secondary storage or the disk. Now when process goes in suspended wait state, when there is no space in the main memory or waiting queue is full. So at that time, the new process which is requesting for the IO need to be swapped out to suspended wait state on the secondary storage. So it has to wait there. And once its IO request is fulfilled and there is a space again in the waiting queue, then suspended wait process again resume back to the waiting queue. Okay, and further it enters in the ready queue for its next execution. So this scenario is handled by the third type of scheduler, that is medium term scheduler. So medium term scheduler is responsible for swap out and swap in. Okay, swapping out the process from the main memory or from waiting queue to the suspended wait state, and again resume back it from suspended wait to the waiting state. Now same thing may arise or same situation may arise when process is in the ready state. Okay, ready state is full and next process, high priority process, want to enter in the ready state for its execution, but as there is no space in the ready queue, so there is again necessity to swap out the low priority process from ready state to suspended ready state, which is residing on the secondary storage, so that next high priority process from the new state is admitted in the ready state for its execution. Now once there is availability of space in the ready state, the process from suspended ready state is again resumed back to the ready state for its next execution. So this is again handled by medium term scheduler. So these are the different states through which process goes through its life cycle. Okay. Thank you.